Namaskaram, welcome to Murthy Telangana. So in the previous classes we have discussed logarithms and surds. So today we are going to discuss about the coordinate geometry. So in the coordinate geometry, first let us concentrate on basics of coordinate geometry. So after that, so in the coming episodes we shall discuss problems on coordinate geometry regarding to the various competitive entrance examinations. So what is the coordinate geometry? So you might have acquainted the knowledge about the pure geometry. So now, whereas all the concepts whatever covered in pure geometry, that shall be applicable in coordinate geometry also. The coordinate geometry will be will be dealt based on algebra. So now, for example, in coordinate geometry, we have the first of all we have distance formula, next we have section formula, next how to classify the triangles, after that how to classify the quadrilaterals, and how to find out the centers of the different triangles. So under different types of centers we discuss centroid, orthocenter, circumcenter, incenter and excenter. After that even we can find out slope of a line or slope of a line segment joining the 2 points. So all these will be covered so during the discussion of the coordinate geometry. Okay, shall we start the coordinate geometry? Okay, let us start the coordinate geometry. So in the coordinate geometry, the first formula is distance formula. See, distance formula. Distance formula. So what is the distance formula? Suppose the distance between the points, say a x1 comma y1, okay, and b x2 comma y2 is given by or is AB equals to root over x2 minus x1 square plus y2 minus y1 square. Even you can change x1 minus x2 square plus y1 minus y2 square, no problem. So this is the formula to find out distance between the 2 points a x1 comma y1 and b x2 comma y2. Suppose instead of a you take origin. So what are the coordinates of origin? We know that the coordinates of origin are 0 comma 0. That means if you replace x1 comma y1 by 0 comma 0 or x2 comma y2 are replaced by 0 comma 0, what do we get? Let us see. Suppose if x2 is replaced by 0, y2 is replaced by 0, we get 0 minus x1 square, that is x1 square plus y1 square. That means the distance from origin to the point x1 comma y1 is root over x1 square plus y1 square. Okay, can we write it? Now the next formula, the distance between origin, say O 0 comma 0, we know that origin is the point of intersection of x axis and y axis. So the distance between O 0 comma 0 and P x comma y or x1 comma y1, no problem, is OP is equal to root of x square plus y square. Okay, next, under distance formula only, so we shall discuss some more points. Suppose the distance between the points A x1 comma y1 and B x1 comma y2, or you write down like this, x2 comma y1. What do you observe in these 2 points? Have you observed anything here? Yes. Here we can observe one thing, the y coordinates of these 2 points are same. Here y coordinate is y1, here also y coordinate is y1. As y coordinates are equal, then the distance between the 2 points is given by the modulus of the difference of the x coordinates. Modulus of the difference of the x coordinates. That means, what is the difference of the x coordinates? x2 minus x1. As distance is measured in actually positive sense, we have to consider absolute value or modulus. So that means the distance between the points A x1 comma y1 and B x2 comma y2 is mod of x2 minus x1. So this is the one of the formulae. Next, in the similar manner, so we shall have one more formula. The distance between the points A x1 comma y1 and B x1 comma y2. So what do you observe in these 2 points? Yes, here we observe that x coordinates of these 2 points are same. Here x1, here also x1. So in this case, so what is the distance between these 2 points? That is the modulus of difference of the y coordinates. So what is the difference of y coordinates? y2 minus y1. Being it is a distance is measured in positive sense, we have to consider absolute value or modulus. So that is modulus of y2 minus y1. So now, under this one more formula let us discuss. The distance between A comma B and B comma A. Okay? The distance between A comma B and B comma A. What do you observe in this case? Are they be equal? No. This order pair does not equal to that order pair. Since it is an order pair, here x coordinate is A, here x coordinate is B. Here y coordinate is B, there y coordinate is A. So they are different order pairs. So now the distance between A comma B and B comma A is root 2 times modulus of A minus B or root 2 times modulus of b minus a. Okay. So, now in the next episodes, so we shall discuss very clearly problems on distance formula. Okay. So, now let us move to the next formula, that is very important formula, section formula. Okay, section formula. Section formula. Now, let us consider a line segment joining the 2 points. So, now consider a line segment joining the 2 points, say A, B. Take any point on this line segment, for example, P. So, now let us have one question in our mind. At what ratio P divides AB, that we have to find out. Otherwise, suppose if P divides AB in the ratio m:n, can we find out the coordinates of P which divides line segment joining the points A comma B? Suppose let us say this A coordinates are x1 comma y1, B coordinates are x2 y2. Suppose P divides AB in the ratio, P divides AB in the ratio m:n. Now, how to find out the P coordinates? Here P is said to be internally itself, not externally. So, that means now we can write the formula. The point which divides the line segment joining the points A x1 comma y1, okay, and B x2 comma y2 is in the ratio m:n. Internally is say P x comma y is equal to suppose this is m, this is n, mx2 plus nx1 by m plus n, comma my2 plus ny1 by m plus n. This is the formula to find out the coordinates of P. Here P divides the line joining the points AB in the ratio m:n. The P internally, the P is given by mx2 plus nx1 by m plus n, comma my2 plus ny1 by m plus n. Okay. Now, suppose P divides externally. Take a line segment like this. Suppose these two are the A and B points. Suppose P. Now, P divides AB externally. Say A coordinates are x1 comma y1 B coordinates are x2 comma y2 if P divides in the ratio m is to n. Now P coordinates we have to find out. P coordinates we have to find out. See, now write down the point which divides the line segment joining the points A x1 comma y1 and B x2 comma y2, in the ratio m is to n externally can be taken as or is P of x comma y is equal to mx2 minus nx1 by m minus n, comma my2 minus ny1 by m minus n, where m does not equal to n. This condition has to be followed. So, okay, let me discuss once again. Let me repeat once again. Because section formula is very, very important, so let us have one more, let us repeat it. The point which divides a line segment joining the points A x1 comma y1 and B x2 comma y2 in the ratio m is to n internally is mx2 plus nx1 by m plus n, comma my2 plus ny1 by m plus n. Suppose externally is there, that is mx2 minus nx1 by m minus n, comma my2 minus ny1 by m minus n. Here m does not equal to n. Okay. So, one more. Suppose this is A point, this is B point. Here let A coordinates be x1 comma y1, B coordinates be x2 comma y2, and P be the midpoint of AB. P divides AB into two equal parts. That means P is a point such that AP is equal to PB. P divides AB into two equal segments. So, that means P is the midpoint. How to find out midpoint coordinates? The midpoint of line joining A x1 comma y1, B x2 comma y2. So, that means since AP is equal to PB, here what does m is to n become? M is to n is equal to 1 is to 1. So, in the place of m you can write 1, in the place of n you can write 1. So, that means already we know the P coordinates are mx2 plus nx1 by m plus n, my2 plus ny1 by m plus n. So, in order to find out the coordinates of the midpoint here, so let us replace m is equal to 1 and n is equal to 1. So, if you substitute m is equal to 1, here we get x2 1 into x2 1 into x1 x1. So, x1 plus x2 by 1 plus 1 is 2, this is y1 plus y2 by 2. It is very simple. The midpoint of the line segment joining the points x1 comma y1 and x2 comma y2 is given by x1 plus x2 by 2 comma y1 plus y2 by 2. It is very important. Same concept may be applied to the circle chapter. The same concept may be applied to the, sometimes if you want to find out a reflection of a point with respect to some other given point. So that is why this concept plays vital role in some dealing with the most important problems in various competitive entrance examinations. Okay, now let us move to next one. So now hereafter, any point on the line can be taken as kx2 plus x1 by k plus 1, ky2 plus y1 by k plus 1. So that means that also write down. So here any point on the line segment joining the points a x1 comma y1 and b x2 comma y2 can be taken as k x2 plus x1 by k plus 1, k y2 plus y1 by k plus 1, where k does not equal to 1. Okay. So this will be useful for solving the problems. So this is the section formula. Okay, next, points of trisection. Points of trisection. What is meant by the points of trisection? This is important concept, so that we have to discuss. So points of trisection means, suppose this is a line segment, say A, this is B. Let us suppose 2 points, say P, here Q. If P divides AB in the ratio 1:2, if Q divides AB in the ratio 2:1, then this P comma Q are called points of trisection of AB bar line segment. I repeat once again. If P divides AB in the ratio 1:2, Q divides AB in the ratio 2:1, then the points P comma Q are said to be the points of trisection of line segment AB or AB bar. Okay? So let us write it. Let P and Q be the points which divide the line segment AB in the ratio 1:2 or 2:1. Then P and Q are said to be points of trisection. Points of trisection of AB bar. Okay, points of trisection, or points of trisection also called trisectional points. Trisectional points. So, some observations, very important observations from these points of trisection we can write it. If P comma Q are the points of trisection of AB bar, so we can have these observations. So, what are the observations means? First observation we can write, or we notice that here AP is equal to PQ is equal to QB. This is first observation. That means P comma Q divide AB into 3 equal parts. That means AP is equal to PQ is equal to QB. And one more important thing, the midpoint of AB is same as midpoint of PQ. That means midpoint of PQ is same as midpoint of AB. Okay. Suppose if P coordinates and Q coordinates are given and you are asked to find out the midpoint of AB, you need not find out A coordinates and B coordinates. Simply find the midpoint of PQ. So, that is nothing but midpoint of AB itself only, or otherwise specifying that if P and Q are the points of trisection of AB, PAB, you are asked to find out midpoint of PQ, it is enough that to find out midpoint of AB itself only. So, that means it is very important for the while solving the problems. Next, the point x comma y divides the line segment joining the points A x1 comma y1 and B x2 comma y2 is, okay, I will write later. First, let us have a discussion. Here, this A x1 comma y1, B x2 y2 and x comma y lie on a same line or lie on a same segment. At what ratio the point x comma y divides line segment joining the points x1 comma y1 and x2 comma y2, that we have to find out. So, that means in order to find out this one, first of all, let the required ratio be k:1, or you can take even m:n also. I already disclosed any point on the line segment joining the points ax1 comma y1 and bx2 comma y2 can be taken as kx2 plus x1 by k plus 1, ky2 plus y1 by k plus 1, that is equated to the x comma y. So, if x coordinates are equated, we get k:1, that is the required ratio. Suppose instead of x coordinate, if you are interested to equate y coordinates, why not? We can equate y coordinates also. If you equate the y coordinates, we get k:1. So, let us do it now. So, as we have here, after that I will write this formula. We can take the formulation. So, let us formulate it. Better you have to remember the formula only, but for the sake of better understanding, so let us try the further generalization. Here, any point can be taken, any point on AB bar can be taken as kx2 plus x1 by k plus 1 comma ky2 plus y1 by k plus 1. Okay, you might have recollected this one. So, instead of this, x comma y is given. That means now this is being equated to x comma y. Suppose kx2 plus x1 by k plus 1, ky2 plus y1 by k plus 1 equated to x comma y. Now, here two order pairs. If you want to equate two order pairs, x coordinate is equated to x coordinate, y coordinate is equated to the y coordinate. So, let us equate it now. So, now this is equated to x, this is equated to y. Now, kx2 plus x1 by k plus 1 equal to x, whereas ky2 plus y1 by k plus 1 is equated to y. Our aim is to find out k value, which determines the ratio. So, that means cross multiply kx2 plus x1 is equal to x into k, kx, x into 1 x. Bring kx this side, x1 that side. Kx2 minus kx is equal to x minus x1. From these two, take out k common, we get x2 minus x is equal to x minus x1. So, k is equal to x minus x1 by x2 minus x. So, using this one also we can find out the ratio. Otherwise, if you equate this one, ky2 plus y1 by k plus 1, sorry, if you cross multiply, you get ky plus y. Bring ky this side, ky2 minus ky is equal to y minus y1. Now, k common, y2 minus y is equal to y minus y1. So, now what is k? Y minus y1 by y2 minus y. Understood? Okay. Now, I will generalize this one now. So, this is the generalization method, but you need not do all these lengthy steps. So, better you confine to these two itself only. This one we have to remember as a formula. That means the ratio at which x comma y divides the line segment joining the points x1 comma y1 and x2 comma y2 in the ratio x minus x1 is to x2 minus x, or y minus y1 is to y2 minus y. The both ways you can remember the formula. Okay, let us formulate it now. Formulation takes place. The ratio at which the point P x comma y divides the line segment joining the points A x1 comma y1 and B x2 comma y2 is x minus x1 is to x2 minus x, or in terms of y and y1 and y2 also you can remember, y minus y1 is to y2 minus y. So, this is very important, and one more result we can remember. So, what are the results based on this one means? One question may be asked in the examination. Examination means in different examinations, competitive entrance examinations. The ratio at which x-axis divides the line segment joining the points A x1 comma y1 and B x2 comma y2. How to find out this one? So, I won't explain the very clear manner. Already we have discussed, only brief discussion. We shall have a brief discussion. If you want to find out that one, in the same pattern how we have generalized this one, we can generalize that one also. Let any point on the line segment can be taken as k x2 plus x1 by k plus 1, comma k y2 plus y1 by k plus 1. As the point lies on x-axis, the point on the x-axis means the general form of the point is in the form of x comma 0. That means y coordinate is 0. So, that means y coordinate is equated to 0. So, k y2 plus y1 by k plus 1 is equated to 0. So, that we get k value that determines the required ratio. So, k y2 plus k y1 becomes 0, k y2 is equal to minus y1, k is equal to minus y1 by y2, that is nothing but minus y1 is to y2. Okay. Let us write it now. The ratio So, next formulation, the ratio at which x axis divides the line segment joining the points A x1 comma y1 and B x2 comma y2 is minus y1 is to y2. Okay. In the similar manner, think for a while the ratio at which y-axis divides the line segment joining the points A x1 comma y1 and B x2 comma y2. Yes, you are correct, that is minus x1 is to x2 only we get it, because on y-axis x coordinate is 0, abscissa is 0. Since abscissa is 0, any point the coordinates of the any point is equated to the 0, we get minus x1 is to x2. Instead of x axis, y axis is there. So, let us write that formula also. The ratio at which y axis divides the line segment joining the points A x1 comma y1 and B x2 comma y2 is minus x1 is to x2. It's very, very important. Okay. So, next, collinear points. Before collinear points, let us discuss area of a triangle. Area of a triangle. So, delta. Area of a triangle using coordinate geometry. How to find out area of the triangle with the help of coordinate geometry? Suppose you draw a triangle, let us say A, B, C. Say A coordinates x1 comma y1, B coordinates x2 comma y2, C coordinates x3 comma y3. Okay. Now, how to find out area of this triangle whose vertices are A x1 comma y1, B x2 comma y2 and C x3 comma y3. Area of the triangle whose vertices are A x1 comma y1, B x2 comma y2 and C x3 comma y3 is given by area of the triangle ABC is delta is equal to half modulus of x1 into y2 minus y3 plus x2 into y3 minus y1 plus x3 into y1 minus y2 small. This is the area of the triangle ABC. Suppose if delta becomes 0, then what do you observe, or what do you infer? If delta is equal to 0, the points will not form a triangle. Then the points are said to be collinear points. So that's why here, if delta becomes 0, they said to be collinear. Collinear means they lie on the same line. If the points lie on the same line, they said to be collinear. If they are collinear, delta is equal to 0. If delta is equal to 0, the points are collinear. So delta is equal to 0, points are collinear. If the points are collinear, delta is equal to 0. So let us have some more observations on the concept of the area of the triangle. This is a B. So let us suppose this is the midpoint of BC, say D. Let us suppose E be the midpoint of AC, F be the midpoint of AB. Just you join DE, FE or DF. Now it divides how many triangles here you see? 1, 2, 3, 4 triangles. If D, E, F are the midpoints of the sides of triangle ABC respectively, then what is the area formed by the triangle DEF? So here you remember this DEF, area of this part 1 equal to part 2 equal to part 3 equal to part 4. So they divide into 4 equal areas. So that means we can write here, suppose you say this is delta 1, suppose you say delta 2, suppose you say delta 3, suppose you say delta 4. Here we observe delta 1 is equal, delta 2 is equal, delta 3 is equal, delta 4, each equal to now 1/4 of the area of the original triangle. That is nothing but 1/4 of area of triangle ABC, or we can write 1/4 of delta. Okay. So now slope. What is the slope of a line? Slope of a line. So before going to the slope of a line, so we shall discuss about inclination of a line. What is meant by inclination of a line? First, we shall discuss inclination. Inclination of a line. Now you consider here, suppose coordinate axis, or we can call it as a coordinate plane. Suppose this is say origin x, x dash, y and y dash. This is x axis, this is y axis. So perpendicular they are, okay. Suppose a line makes angle theta here. This is known as anti-clockwise direction. Anti-clockwise direction. See, this theta is known as inclination of the line. So suppose you say this line is L. What is the inclination of line L? That is theta. So now how do we define? The angle made by the line with x-axis in anti-clockwise direction is called inclination of a line and denoted by theta. Okay? So that is the inclination of the line. Suppose, now write down the angle made by a line with x-axis in anti-clockwise direction is called inclination of a line. Inclination of a line denoted by theta. Some Greek letters. It may be denoted by alpha or beta, gamma, like that, vice versa. Generally, we denote it by theta. So since theta is the inclination of a line, then now let us discuss limits of the inclination. So what is the range of the inclination? Suppose, let us consider one more example for inclination of a line using visualization, that means using diagram. Suppose inclination may be like this. X, x dash, y and y dash. Suppose if a line subtends are made angle like this, say suppose this line is M line, this is theta. See, in the previous case theta is acute, that lies between 0 to 90 degrees. If you observe theta here, that is more than 90, that is obtuse. So theta may become, for example, if the line coincides with x-axis, what will happen? Just rotate it like this, you think. Then theta may become 0, but theta may not become 180 degrees. The range of theta is, inclination of a line is, so lies between 0 and 180. It may be equal to 0, but it may not equal to 180. So that's why the range of theta is written as like this: 0 degrees less than or equal to theta, theta less than 180 degrees. That's why we conclude that theta always lies either in first quadrant or second quadrant only. That's all. You remember that concept. See, so far we have completed some basic concepts on the coded geometry. Some more concepts in the next episode we shall discuss. So thank you for watching. Thank you one and all.